Okay, so here we're still looking at chapter 7 today. And last class for chapter 7, we were looking at the normal distribution. Today in chapter 7, we're going to study the standard normal. Distribution. So as you notice in the name, it says normal. So as you probably can guess, it's still going to be bell-shaped or symmetric. You're going to notice that's what we're going to really focus on the rest of the semester. So when we have this standard normal, distribution, this is when we have our mean or our center equal to 0 and our spread or standard deviation is equal to 1. Let me just make a note of this. So mean, we can call this mu. This is the center. And then we have sigma. This is my spread. Let me just write here, mean, standard deviation, okay? Just so we understand what our symbols are representing, okay? Now, last class I gave you some notation, right? And I said that X follows a normal probability model, and I gave you the center and the spread. And we're going to do the same thing for today, but it's not going to be X any longer because X represents a data value we're interested in. Today, we're going to represent this with the letter Z. So Z follows a normal probability model, and we have our center and we have our spread. So I want you to notice here, Z, first of all, this is new for us. And what Z represents is I want you to think about the Z-score. So do you guys remember Z-score way back in chapter 3? Z-score was just my data value minus my mean divided by my standard deviation, right? And we could use X bar and S in here for studying a sample. And what this represents is the number of standard deviations. A value is from the mean. Okay, so that's what my Z-score would represent. It was give me some data position, right? It told me how many standard deviations my value that I'm interested in is away from that mean. And it's still going to represent the same thing here today when we're looking at Z. It standardizes everything, hence the name, standard normal distribution. Now here, if we think about last class, we had our normal probability model. That's what N stands for. It still does. And we talked about what these numbers would represent. And last class I said, well, it's the center and the spread, it's the mean and the standard deviation, and it still is. It's just there's numbers in there instead of symbols because it doesn't change. It stays at 0 and 1. My center or my mean is 0 and my spread or my standard deviation is 1. Okay. So when we're looking at a standard normal curve, it standardizes our data for us, and our center and spread will always be 0 and 1. Now, what I want you to recognize is when we're looking at some notation for the probability side of things, there's a couple key pieces or one specific key piece that you're going to notice so you know you're studying the standard normal curve. So if we're looking to find the probability, that A is less than whatever we're studying is less than B. What it is that we're studying is Z. And Z right here is key. Okay, this Z is telling us that we're on the standard normal curve. That's the key. So if I'm calculating a probability and I'm using notation and it has a Z there, I automatically need to know this is my standard normal curve. Again, we're going to use the same thing as we did last class. So last class, if you remember, we used the normal CDF, and we're still going to do that. So my normal cumulative distribution function, same thing. It's just what I'm plugging in changes. So if I'm on my standard normal curve, then I need to know that my center is 0, my spread is 1. So normal CDF, okay? And you're going to plug in your lower bound, which is A, your upper bound, which is B, your center, and your spread, 0 and 1. That's when you're finding a probability. I'm trying to think how I want to write this. So finding a probability. So what your picture looks like, and I encourage you guys to draw pictures all the time going forward, wherever A is and wherever B is, I don't know, here. And we're finding this. But I should know that the center of my curve is 0 and the spread is 1. Like this. If I was putting 1, 2, and 3 standard deviations away. Okay. So that's the kind of thing we're looking at. There's something else we can look for, right? If we're finding a probability, that's one way. Another thing is that we can find a percentile. So meaning that I'm going to use the inverse. I'm going to work backwards, meaning that I have the percentage, I have the probability or the area under the curve, and I'm going to look for the data value. So I can do that as well, right? So we did this last class with the normal curve. So now we're just going to apply it to the standard normal curve. So a percentile of Z again, Z is my key. Here we're going to use the function inverse norm. And just like last class, I'm going to plug in the area to the left. I'm out of room, so I have to write it like that. And then again, my center and spread, 0 and 1. So these do not change. This is always 0 and 1 for Z, the standard normal. So we have to recognize when we're on that standard normal, and that's the Z. I'm just going to write that up here as well, just so we have that right here. Oops, I tried to circle. So I'm going to just write that. Always 0 and 1 for Z, standard normal. Now, keep in mind the inverse function is very similar to an inverse function in algebra class. Meaning, if we have a function in algebra class, it'd be y equals mx plus b, right? And you could plug some value of x in to find a value of y. What an inverse function does for us in algebra is it allows us to plug a value of y in to solve for a value of x. The same thing's happening here. So if you're using the normal CDF, that means you have data values down here and you're finding the probability. So this is like what we're finding right here, this area. Okay, and I have these values. And what the inverse function does for us, just the opposite. So the inverse takes my curve here, and I have a percentile. So I have to go think back to the percentiles, and I will know what this percentile is. It might be whatever, a percent. I don't know. And we're going to solve for this data value here. Okay, that's what the percentile does. I have the probability, the area under the curve, the percentage. I'm solving for that data value. Okay. Now, if we want to find an area, like maybe I have the area between two values and I need to find the two values, I need to be tricky about it, right? I need to kind of maneuver things around and find a couple different values to find this. Meaning I would have to calculate all of this area to the left to find this value, right? And I'd have to find the area to the left of this to find this value. So I can do it. I just have to do a little bit more work when I don't have just the less than. And the same thing if I wanted to do like a greater than. So maybe I wanted to find the area to the right up here. Maybe I just want to find the area to the right here. Well, it would just be 1 minus the A, or 100% minus the A percent would give me this area here, right? So I could still find it. It's just I kind of have to maneuver things around, and I have to, I have to think a little bit more than if I just have a straightforward problem of the area to the left. So let's take a look at the standard normal curve, and I'm going to apply it to the same example as we looked at last class. So think about last class, we had the student heights from my Stat 1 last semester. So let me just say same info as last class. So if we remember, we were looking at the student's height, and it had a mean of 68 inches, and I believe the sigma, I'm trying to look, 2.5 inches, right? So I'm going to draw that curve, and I'm going to apply the standard normal to it in just a minute. So if I have my normal curve, the center here was 68. Now this is what we did last class. And then I did 1 standard deviation above, 2 standard deviations above, and then 3 standard deviations above. And then the same thing on the negative side where I subtracted 1 standard deviation, subtracted 2 standard deviations, and subtracted 3 standard deviations, right? So that was my normal curve. This is what we would call X, right? Like we did last class. Now, if I wanted to apply this for our standard normal curve, all I would do is everything would look exactly the same. It's just I would have a new horizontal axis that now is named Z, and the center is 0. And I have +1, +2, +3. You don't have to write the plus. I just showing you it's positive, and over here is negative. And this is all it does. So when you're studying a standard normal curve, your horizontal axis is just Z, and it's 0, 1, 2, 3, -1, -2, -3. Okay. So it really doesn't change much. What it does is it's just saying that 70.5 is 1 standard deviation above my center. 73 is 2 standard deviations above, right? So you can see how it directly relates to those data values. It just standardizes everything. So maybe I say, well, it's not fair to study the students' heights for males and females all together. Maybe I think we should take the males and take the females and standardize them all, okay? And then once we standardize them all, then we can look at them all together, because now we're comparing apples to apples, right? I mean, we're comparing height, which is fair, but maybe I'm going to say, well, I don't think that's fair. I'm short. And maybe I don't want to be compared to someone that's over 6 feet tall. It's a male, right? So then we're going to standardize everything. That's what that standard normal curve does. So let's take a look at applying some tools and using our technology to find some probabilities based on that standard normal curve. Okay. So I'm going to try one that's a probability and then another one that's finding a percentile. So meaning I'm given the probability, but I'm going to find that data value. We'll do that one second. So let's just say, what is the probability? I like to write it out in words so you guys get a feeling for the words and what it's going to mean to you in notation. That Z, because now I'm talking about Z, I'm not really talking about individual students' heights anymore, right? I'm talking about Z now, is less than, let's just pick -2. We could do any value, right? It doesn't have to be one of those. All right, let's just do -2.2 then, just to show that it doesn't have to be. And I'll put a 0 so you know it's not like a mistake, okay? So when I do something like this, I'm going to use my technology. So last class, I showed you on your calculator, and that's kind of what I wrote out over here when I said the normal CDF or the inverse norm, okay? So if you have a calculator, you can follow along. If you do it on your own, if you use Minitab, I'm going to show you guys Minitab right now. So I already opened up a Minitab file, so I'm going to share my screen for that so you guys can see. So here's my Minitab. It doesn't have any information in it, and I don't need any information in it. When you're calculating probabilities for Minitab, all you need to know is what your area, we're looking for the area to the left. I need to know what that data value is. So actually, you know what? Let me go back to this and just show you the notation. So since I'm searching for a probability, I'm going to start with capital P, and it says that Z is less than -2. So I have Z is less than -2.20. Okay. And now I know, okay, I'm finding a probability. So find the probability, right? Then I also see that I have a Z here. This Z is standard normal. That means I'm looking at this horizontal axis, the 0s, 1s, 2s, and 3s. If it was X, I would be studying the student heights like we did in last class. Although I'm still studying student heights, it's just now I've standardized them. Okay, now let me show you my Minitab. So I'm going to go back in just to this blank Minitab screen. So if you want to calculate a probability, you're going to go up to the top menu here, and you're going to go right up to Calc. Once you get into Calc, you can see the second from the bottom says probability distributions, and that's what we need to look for. And if you think about it, we're in the normal distribution, right? We're in the normal bell-shaped curve. So we're going to go over to the right and all the way up, second from the top. It says normal, so I'm going to choose that. Now, if you have a Mac, it might look slightly different. And all I mean by that is you may have to choose what I'm going to choose next before you get into your next screen. So I think if you have a Mac, it's going to say, well, is it a probability density, cumulative probability, or inverse? So you're going to choose cumulative probability when you're calculating a probability. And that is already chosen here for me. That's the default on my side. Then if you look here, it asks for the mean and standard deviation. What this is trying to say is what is the center of your curve and what is the spread of your curve. This defaults to 0 and 1, and that's exactly where I want it. I want it at 0 and 1 because I'm on the Z curve. Now here it asks for input column or input constant. Input column means I have a whole bunch of data values in a column over here, and I want to find the probability of all of those values individually. I don't have that. I just have one. I just have the one value of -2.2. So I'm just going to come up here and plug in -2.2. Okay. I can click OK. My output's very simple. It shows, okay, I have an x of negative 2.2. It shows x because it doesn't know the difference between standard normal and normal, right? On my Minitab side. And right here is the probability. So the probability is equal to 0.0, I'll say 14. I'll just round it. So now I'm going to go back to this. I wrote that 0.014 is my answer, or you can write it as 1.4%. And that's the probability. So what that's saying is that the area under the curve is a very small percentage, right? So if you were to draw this out, and I'm going to squeeze it in here, and I can always zoom in if we need to. If you draw your curve, all you really need is a 0 here, and you're interested in this negative 2.2. So what you're looking at is this area right here is the 1.4%. That's that area in that tail. So you guys, I really love when you draw pictures all of the time. It's so helpful because sometimes someone has a hard time taking the words and writing the notation like this. But sometimes they could take the words and draw a picture, and then from the picture, you can draw the notation. What happens is when you do this, this is what sets you up for what you're putting into your technology, right? Keep in mind, Minitab will always give you area to the left. So even if I put positive 2.2, which would have been up here, it would give me all of this area to the left. It wouldn't give me area to the right. So if I want area to the right, I would have to subtract the area from the left from 1, right? So if I wanted all of this area to the right here, I would take 100% and subtract the 1.4%. And that would give me all of this, okay? All right, let's take a look at another example using the same stuff, but let's try a percentile, meaning I have the percentage, I have the area under the curve, but I want to find a corresponding data value. So find the 99th percentile. Okay. So here, when I'm finding the 99th percentile, I'm going to draw this out actually first. That doesn't even look like a good curve, but you guys get an idea of it, I think. Something like that. 99th percentile. Think about what that means. 99th percentile, this right here, means 99% to the left, 1% to the right. That's what that means. So I'm looking all the way up here, okay, and I'm trying to find this data value because I know that this is going to be 99% or 0.99, the area in that curve, okay? Sometimes we have to look and read the problem. What if it said something like the top 1%? Well, that would mean that, okay, I have a 1% up here on the right, but I'm still looking for that same data value, right? So that still is 1% up there. But maybe it said like the top 30%. So that means I'm up here. It means I have 30% here and 70% here. But when the wording is 99th percentile, 40th percentile, it means whatever that percentage is below to the left and the rest is to the right. Okay. So let's see how we're going to do this in Minitab. You could follow along or you could try it out on your calculators if you are using a calculator this semester. If you're using a calculator, you're just going to use your inverse norm. I'm going to do the same thing on Minitab. I will be using the inverse norm. I'm going to go back into my Minitab. I don't have to start anything new. I could just keep going from here. So again, I'm going to go back into the same spot, which was calc probability distributions, and back into the normal. Guys, remember, this is all typed up. So I have all these directions typed up. Sometimes it's just nice to be shown, right? So I give my normal. So if you're on a Mac, I believe you have to choose inverse before you can get into a page here. Like I have to choose just normal and then I have to choose inverse. I think you just have to choose inverse first. So I'm choosing inverse. because I have the percentage, which is 99%, I want the data value that corresponds with that. I'm still in my standard normal curve, so I'm still going to use 0 and 1. I still only have one percentage that I'm going to study, so just a constant. So here I need to take this out, and that you just have to know if you're studying an inverse, it wants a decimal, so 0.99. If you try putting in 99, you're going to get an error. So anything above 1, you will get an error here. So it has to be a number between 0 and 1. So 0.99 to represent that 99th percentile. Remember, it's the arrow to the left. I'm going to click OK. And then here, I get the answer to be 2.326. Okay. So it says, okay, the probability is 99%. And here's my data value. So I just went back to my drawing and I just wrote, okay, it's 2.326. That's my data value. Remember, it should be a number, right, around there because I'm looking at my standard normal curve. If I'm outside 3 standard deviations away from my center, I have a very, very tiny probability, okay? So it should make sense to you that this is 2.362. Not that specific number, but that it's around 2 to 3, okay? And it just happens to be 2.3. Okay, so that's how we use our Minitab. And we went over the calculator last class for finding the percentiles and finding probabilities. Okay, so that was for the normal and standard normal curve. I have one more thing I'm going to talk about before we're done talking today. And that is what we call assessing normality. So you know how I mentioned in the beginning of class that we're going to work with this normal curve and we're going to focus on this. Well, we need to make sure we have normality. So we need to assess for normality to make sure that I'm using the correct curve. So I don't really want to find a percentile based on the normal curve if my data is not normal, right? So that's the first thing I need to kind of make sure is my data normal or normally distributed? All I mean by that is it bell-shaped, okay? So sometimes when we're looking at a sample, it's really hard to tell, we're not sure, okay? So we have a couple things we can do. So if you want to just be visual about it, you can look at the histogram. So we can say yes, if the histogram is bell-shaped. So that's one way to tell. Another way to that we can tell is if we are told. So I told you last class that the student heights were normally distributed. I told you it was symmetric. So that's another way to say confirm, okay, when I assess normality, we're told that it's normal. But what if we don't have these, okay? So what if we can't tell from the histogram? Maybe there's not really enough information from the histogram to really get a good idea of what's going on. Then we have this third way. And this third way is called a normal probability plot. And it's actually just called the NPP. So it's the normal probability plot. It's the NPP. What this does is this looks like a scatter plot. Remember the scatter plots from chapter 4? When we had an X and a Y, that's what it looks like. It looks just like a scatter plot. And what this does is our technology will build this for us. I just have to give it the raw data. So I just have to give it our values. And our technology will build this plot and it will plot our values. So of our data values versus normal values. And that's what it's a scatter plot of. So what happens is our technology takes our data values and it finds what would be normal for our data. Meaning it probably finds like the center and the spread, right? And if it was normal, how it would be distributed, and then it plots our points versus the normal values, okay? What should be normal for this overall data set. And all we need to do is we need to look to see if this is fairly linear. So if the NPP is linear, and I'm just going to say fairly linear because nothing's perfect, then our data is normally distributed. So I'm going to show you this real quick. I'm going to show you how to get this. So let's see. I'm going to show you in our calculators first. So in order to do this, I have to have data. I don't have a specific example I want to show you. So I just have data in here from whatever other class. So you would go to Stat Edit, and you would just take some data values. So I have these data values. I don't remember what this is from. This is from our exam, I think. If I look at this, these data values in list 1, okay? So I have these in here, and so what I would do is put them in there, just in my list. Any list, just make sure you note which list it is. Now I want to plot them, so I'm just going to get out of here by second, quit. I'm going to go up here to the stat plot, so I need to do second, and then stat plot, which is the y equals. So click that. I'm going to get into one of the plots. I'm just going to go into the first one. I want to make sure it's on so that the on is highlighted. And then I'm going to arrow down to, sorry for the glare, by the way. I'm going to arrow down to the type of graph. So for an NPP, I want you to know it's this very last one that I have highlighted. You can't arrow down. Look what happens if I arrow down. I go down to the data. You have to keep arrowing over and then hit enter. But that's the one I want, the last one. That's my NPP. When I arrow down, I need to tell my calculator which list I'm using. I'm just going to use list 1 and then arrow down, and you're going to click zoom here and then the number 9. And it's going to give me a normal probability plot. This does not look linear to me. Look at this curve. This is not linear. So to me, and it doesn't have to be perfect linear, it's just fairly linear. We're going to say it's normal. This does not look fairly linear. I'm going to say, no, I do not think this is normally distributed. Okay. If you're in Minitab, I don't have it in here, but I'm just going to show you guys. So if we're in Minitab, just going to open this up real quick. So if we're in Minitab, I'm going to show you where to go. I don't have my data in here. I mean, I could just randomly put them in, but I don't want to spend the time. We're going to go to graph, and you'll notice, sorry, about a third of the way down, it says probability plot. That's your NPP. You just click on that. You're going to choose single. It just means I have one column of data I'm interested in studying. Click OK. You'll bring that column in and then click OK again. There's nothing tricky you have to do. You don't have to click on anything special. Again, this is all in not the notes, but the daily or the weekly assignments, the team assignments. It's all typed up. Okay. Any questions on that stuff? So I tried to show a mix of the Minitab and the calculators. I felt bad. I left the people out that use Minitab last class. Any questions?